All right, so page 513, and we can do any one of them, 7 through 12. I don't know if we, can we just pick one? Number 8. Okay. Number 8. So here's the information we're given, that the cosecant of x is negative 7/6, and the tangent of x is positive. Okay? All right. So we want all the trig functions. Cosecant of x is negative 7/6. Would we be good saying sine of x is negative 6/7? Get that right out there. Okay. I'm going to, I think I'll just use that. Sine squared x plus cosine squared x equals 1. Now, I was actually going to try to derive, what goes with cosecant with the Pythagorean identity. And you might have it memorized. I really don't. I always have to kind of derive it from this. But I'm seeing here we got sine, so we can get cosine with that, right? All right. So let's take negative 6/7, square that, add cosine squared x, and that'll equal 1. And we'll solve for cosine of x. And that is 36 over 49. We're going to get two solutions, plus cosine squared x equals 1. And if I subtract 36/49 from both sides, I'm getting cosine squared x, that's 49/49 minus 36/49 is 13/49. And I take square root, and I get plus or minus the square root of 13/49. So cosine of x is either positive radical 13 over 7 or negative radical 13 over 7. In this case, the sine is negative, the tangent is positive. What's the cosine got to be?
Negative.
Cosine has to be negative. So we have to choose the negative one. So let's go cosine of x is negative square root of 13 over 7. So far, so good? And then let's go with the reciprocal here. So that means the secant of x is negative 7 over square root of 13. And let's rationalize that denominator and get negative 7 radical 13 over 13. And then tangent. Use this identity. Tangent of x is sine of x over cosine of x. And sine is negative 6/7. Cosine is negative square root of 13 over 7. We'll keep, we'll change, and we will flip. So we're going to get a positive, like we were supposed to. 6 over square root of 13. And okay, all right. If I rationalize the denominator, I get this, right? So tangent of x is 6 radical 13 over 13. And then cotangent is the reciprocal of that. And if I go here, it's a little easier to get the reciprocal. Square root of 13 over 6. And I don't have to do any simplifying. All right, how's that? So that's the first problem you'll do Monday. Okay, so page 513, number 48. Cosine of x over 1 plus sine of x plus 1 plus sine of x over cosine of x. What's the, what do you think we ought to do to look for here?
Common denominator.
Common denominator. Get this into one. Instead of the sum of two rational expressions, get it into one rational expression. Okay, so let's, cosine of x times 1 plus sine of x, everybody agree, common denominator? So I'm going to multiply this one by cosine of x over cosine of x. Blurry. Okay. And then let's go 1 plus sine of x over 1 plus sine of x times this one. 1 plus sine of x over cosine of x. All right? So we got cosine squared x plus, I'm going to multiply these two together. That's 1 plus 2 sine x plus sine squared x. That's over cosine of x times 1 plus sine of x. Michael?
What do we do to get steps before? Like with the cosine of cosine.
Okay, I'm going after, yeah, I'm going after the common denominator. So the product of these two is the common denominator. This one does not have the cosine x. This one does not have the 1 plus sine x.
Okay.
So I'm essentially multiplying this by 1.
How are we allowed to, because they're on the same side of the equation, how are we allowed to multiply them by different things?
Okay, but what am I actually multiplying by?
1.
Can I multiply something by 1 and not change it?
Okay.
Yeah. So that's yeah. If you're thinking of solving, you got to do what to one side what you do to the other. But we are essentially just multiplying each of these by 1, and then we're going to combine it. Okay. Good questions. I am going to look at this now. I'm going to rearrange the top because I think I see something here. If I go sine squared x plus cosine squared x plus 1 plus 2 sine x, just rearranging the numerator a little bit. Then I have cosine of x times 1 plus sine x. Do you see an identity there?
Sine squared x plus cosine squared x equals 1.
Right. So we got 1 plus 2 sine x over cosine of x times 1 plus sine x. And that's 2 plus 2 sine x over cosine of x times 1 plus sine x. I'm going to factor out that 2 in the top, and I have 2 times 1 plus sine x over cosine x times 1 plus sine x. Common factors can cancel now that it's in one rational expression. So 2 over cosine x I'm going to go a little further with that. That's 2 times 1 over cosine x, which is 2 secant x. There's a lot in that we did. All right, so this is page 531. It's number 63, and it is, we're solving a trig equation here, and the trig equation is 2 sine squared x plus 5 cosine x equals 4.
What page is this on?
531. All right. Okay. Having two different trig functions, unless you can kind of work it through intuitively, it's better to get it down to one trig function. And what do you think would be a good step here then?
Change sine squared x to 1 minus cosine squared.
Okay. All right. No, it's all right. It's all right. Okay. Then we are just dealing with cosines. So I've got 2 minus 2 cosine squared x plus 5 cosine x equals 4, just distributed. Looks like when I have this, I want to get it equal to 0. Right, so I'm going to subtract 4 from both sides, and then just kind of rearrange it and go negative 2 cosine squared x plus 5 cosine x minus 2 equals 0. Okay. If I got a factor, I kind of like this one to be positive. If I got 0 here, I can change all the signs. So basically what I'm doing is multiplying both sides of the equation by negative 1. And negative 1 times 0 is still 0. Okay? So that is 2 cosine squared x minus 5 cosine x plus 2 equals 0. All right, I'm going to do a side problem here. 2u squared minus 5u plus 2. I want to factor that and then transfer it to u being cosine of x. All right. So what multiplies to 4 and adds to negative 5? Sophia?
Negative 4, negative 1.
Negative 4, negative 1. All right. So 2u squared minus 4u minus 1u plus 2. Let's go 2u times u minus 2, negative 1 times u minus 2, okay? So 2u minus 1 times u minus 2. If you use this, if you do the guess and check and get to this quicker, that's good too. All right, so I've got it factored now. 2 cosine x minus 1 times cosine x minus 2 is equal to 0. Two cosine x minus 1 equals 0, or cosine of x minus 2 equals 0. I add 1 and then divide by 2. I'm going to have cosine of x equals 1/2, or cosine of x equals 2. All right, this is not possible. Cosine of any angle is between negative 1 and 1. 2's too big. So let's just deal with this. All right, where's the cosine of x equal to 1/2? Cosine 1/2. So like here, we're talking, this is pi over 3, right? And down here, this is 3 pi over 2. So that's 9 pi over 6. 10 pi over 6 is 5 pi over 3. So I'm getting x equals, do they tell us, what number is this, 63? All right, we're going to go after all solutions. So x equals pi over 3 plus 2 pi n, or 5 pi over 3 plus 2 pi n.
Mr. Gilmore,
Yes.
why is cosine x equals 2 not possible?
The cosine of an angle is somewhere between -1 and +1.
Oh, okay.
Okay? It's outside of the domain. Outside of the domain of the inverse cosine. Okay?
So if there's one that's not on the circle, so if it's like not in the domain, it's not possible. But if there's one like not on the circle, you use the inverse. Or
You
whatever.
can write, if you want the exact, you'll write arc cosine of 1/2 or whatever. That's on the circle. Or
Would that be on the test?
I think I'm limiting it to unit circle problems. And if we wanted to approximate, we'd just use the calculator.
Okay.
And we would just do that in the calculator. Okay? All right. Okay, so, and we're starting with secant of x equals -5/2. Tangent of x is less than 0. We've got secant of x is -5/2. Cosine of x is -2/5. Sine squared x plus cosine squared x is equal to 1. And we know cosine, right? So sine squared x plus -2/5 squared equals 1. Sine squared x equals 4, nope, plus, not equals, plus 4/25 equals 1. So I'll subtract 4/25 from both sides. Sine squared x equals, now that's 25/25 minus 4/25, which is 21/25. Time to take the square root. We have a positive and a negative square root. So the sine of x is equal to the square root of 21 over 5. And it's plus or minus. Which one is it, though? If cosine is negative and tangent is negative, what's sine got to be? Sine's got to be the positive. So we're going to choose the positive one here. Square root of 21 over 5. Cosecant of x, that's 5 over square root of 21. And if we rationalize the denominator, I got 5, 5 radical 21 over 21. And then I know sine and cosine, so I can get tangent. Tangent of x is sine of x over cosine of x. Square root of 21 over 5 over -2/5. And I'm going to keep, change, and flip. 5s will cancel. So I'm looking at tangent being negative square root of 21 over 2. And then cotangent is the reciprocal of that, so negative 2 over square root of 21, and I'll rationalize the denominator and get negative 2 radical 21 over 21.